Alright, in the last lecture we have learned how to traverse and reverse traverse through CircularDoublyLinkedList. Now in this lecture we are going to use traversal to find the given node in CircularDoublyLinkedList. So let's say we have a CircularDoublyLinkedList like this. So basically the logic is we are traversing through the all elements of CircularDoublyLinkedList and check that if this is the element that we are looking for or not. So we are going to visit the first element and compare it with the value that we are looking for, then second, then third, and so on. So let's say in this case, for example, if we want to look for, so how can we find it? So the first thing that we are going to do, we are going to visit the first node and check that if this is the node that we are looking for or not. Now in this case, you see that in the first node we have the value of 1, so this is not the node that we are looking for. So we are going to continue to the next node. So when we go to the next node, we are going to do the same operation. So we have if condition over here. If the value is equal to this value, we are going to print out to the console saying that we have found it at this location. If it is not, we are going to continue to the next node. Now you see that in this case 2 is not equal to 4, so that's why we are going to continue to the next node. So the same operation is applicable over here. So we are going to compare the node's value with the value that we are looking for. So now we see that it's not the value that we are looking for, so we are going to continue to the last node. Now when we reach this node, we see that this is the value that we are looking for, so this means that we are going to stop over here and saying that the value is found at the node of 4 over here. So with this we are going to terminate our search operation over here. Now in the worst case, if we cannot find the node that we are looking for, in this case when we reach the last node, we are going to stop and return message saying that the value does not exist in our CircularDoublyLinkedList. Now the algorithm of this search operation will be like this. So our algorithm starts with the node value, so it's going to take node value. So this is the value that we are searching in CircularDoublyLinkedList. Then the next thing that we are going to do, we are going to check that if head exists or not. So if head equal to null, it means that our CircularDoublyLinkedList does not exist. So this means that we can stop over here and return message saying that the CircularDoublyLinkedList does not exist. Otherwise, we are going to continue to the first node. So in the first node, the first thing that we are going to do, we are going to check if the node value is equal to current node. Then in this case, we are going to return saying that this node is found over here. Otherwise, we are going to continue loop through all nodes over here. Then when we are reaching the last node, we are going to stop over there. So that's why we have if condition over here. If the current node is equal to tail, so this means that we have reached the last node. So we have to stop over here. So our algorithm will stop over here. Now, based on this algorithm, let's create search method in practice. So here again, inside CircularDoublyLinkedList class, we are going to implement our method after reverse traversal method. So it's going to be search for a node method. So our method will return Boolean value, because if the node is found in our CircularDoublyLinkedList, we are going to return true. Otherwise, we are going to return false. So I'm going to declare it like this: Boolean, and the name of method will be search node. So as a parameter, it's going to take the type of integer parameter, so it's going to be node value. Now then, the first thing that we are going to do, we are going to check that if head is equal to null or not. So I'm going to put if condition like this: if head is not equal to null, this means that our CircularDoublyLinkedList exists. So in this case, we can continue our operations over here. Otherwise, we will return message saying that node not found in this CircularDoublyLinkedList over here. So the first thing that I'm going to do, I'm going to create a temporary node with the type of Doubly node and assign head value to it, because we are going to start loop through the first node. So that's why I'm assigning head to temp node over here. Then inside this loop, integer I will start from 0 and it will continue until we reach the size of CircularDoublyLinkedList. Basically the logic over here is same as the logic of the traversal, but here we will have extra if condition. So inside this loop, we are going to have if condition. Now, in case of traversal, inside this loop, we were printing out the value of CircularDoublyLinkedList node, but here we are going to check that if this value is equal to the node value or not. So in this case, search operation will be like this. So I'm going to write if condition like this: if temp node dot value is equal to node value that we are looking for, then in this case, we are going to print out message to the console saying that node found at the location of I. So in this case, I is the index of node in our CircularDoublyLinkedList. So in this case, I'm going to print to the console, the node is found at location. So I'm going to concatenate it with I. Then after doing so, we are going to return true, because we have mentioned that if the node exists in our circle double linked list, we are going to return true. Otherwise, we are going to return false. Now, outside this if condition, we have to set temp node to temp node.next, because in this case, in each iteration, we have to traverse to the next node. If the value that we are looking for does not exist in the current node, this means that we have to check it with the next node until we reach the last node. So that's why we put over here size of the circle double linked list, because this loop will continue until we reach the size of double linked list. Now then, if we loop through this circle double linked list and we cannot find the node that we are looking for, so we have to inform a user that the node does not exist in our circle double linked list. So to do so, I'm going to print to the console the message that node not found. Then after doing so, I'm going to return false, because as we mentioned before, if the node is not found in our circle double linked list, we have to return false in this case. Now with this, we have completed our method. So basically what we are doing over here is we are searching through a circle double linked list, and in each iteration we are comparing the current node's value with the node value that we are looking for. If this exists over there, we are returning message saying that the node is found at this location and returning true. Otherwise, we are continuing to the next node, and we are continuing this until we reach the last node. So when we reach the last node and we cannot find the node, in this case we are returning message saying that node not found. Now let's see how this is working in practice. So here we have created a circle double linked list like this, and we have inserted nodes to it. So I'm going to call traversal to see the circle double linked list in proper way in our console. Then I'm going to search, for example, for the value of 3. Now we know that value of 3 exists in our circle double linked list, so it should return true in this case, with the message saying that not found at this location. Now when we run our code, you see that our circle double linked list is like this. So 3 is located at the index of 2, so that's why the message saying that the node is found at the location of 2. Now if I put, for example, over here looking for 9, in this case, if I run our code, you will see that in this case it will not be found in this circle double linked list. So it says that node not found. So this means that 9 is not exist in our circle double linked list. So as you see, our method works without any error in practice. Now let's see what's the time and space complexity for this method over here. Now as always, we are going to start from the first line of this method. So in the first line, we are checking head if it is not equal to null or not. So in this case, it will take O1 time complexity. Then we have created temporary node, and here we have assigned head to this temporary node, and this one also will take O1 time complexity. Then we are starting looping through the first node of circle double linked list until we reach the last node. Now in the worst case, if the node is located at the end of circle double linked list, so this will take ON time complexity. Then inside this loop, we have if condition over here, and based on this if condition, we are printing out message to the console. So now this if condition over here will take O1 time complexity, because in this case we are just checking the value and printing out message to the console. Then in the next line of code, we are setting temp node.next to temp node. So in this case, it will take O1 time complexity. Then at the end, we are printing out message to the console saying that node not found. So this one also will take O1 time complexity. Now if we combine all these complexities over here, we get ON time complexity, because as I mentioned before, O1s are non-dominant terms in this case. So ON is dominant term, so O1s will be eliminated from here, and the time complexity will be ON. Now the space complexity is O1, because in this case an extra memory is not required to perform this operation over here. That's why space complexity is O1. Now with this, we have come to the end of this lecture. So in this lecture, we have explained how can we find a node in circle double linked list, and we have learned what is the time and space complexity for this operation over here. Now see you in the next lecture.